19, problem 3, and we have these 3 blocks, and we have a cable that's holding block A to the wall. We're pulling on block B, and we want to see what the smallest force is that's going to cause motion here. So we want to make sure that we do all of our FBDs. Probably going to be a good idea to do 3 FBDs. So let's check them out. Okay, so here's the problem all written out in my chicken scratch. And let's make some FBDs. And if I can be if I can economize, I could probably get them all to fit in a row right here and then just do my stuff underneath them. Because they don't really need to be very big. They just need to look like little blocks. Alright, so here's my little FBD of this one. If I use my little squares a little bit better, I could have predicted that a little better. Okay, and then there's this guy, last guy. FBD. Yeah, I should have moved him over just a little bit more over there, giving him a little bit more room. And he's getting all crowded. Okay. Now, I don't know the answer to this one yet. Okay, so I'm thinking it through as we're coming through here. Hopefully that has some type of benefit. All right, so this one's going to be A, and he's going to have the weight of A coming down this way, and there's going to be the normal force of A. I think that's fine. He's also going to have a force right there, right, of this tension, and it can't push rope. So this is, I'll call this FT, right? This one already is called P, so FT isn't taken. So if FT is that direction here, that means that if this is an equilibrium and you can't push a rope, that the friction force right here, this F, and we'll call this AB. Maybe this is FNAB. Yeah, that's fine. All right. Now, no, we don't know. Well, the only thing we can find right here, we could say the sum of the forces in the y direction is equal to 0. So, negative this plus FNAB equal to 0. FNAB is just going to be equal to 10 pounds. Right? And so the FFAB, and I'm going to be careful here not to think, just because that is written down as this is going to be the friction, the S right there. I'm going to put an S right in there, just to make sure, comma S. This is not that force. This is the breakaway force, right? And, let me see here. I need to write that AB. So 0.3 times 10, 3 pounds. Right? But we don't know for sure that that's 3 pounds yet. Right? Now, we're going to have a force down here. And this is going to be FNAB, which we know, 10 pounds. And then we're going to have the weight of B. We're going to have the FNBC. But here we have to be careful. We're going to have the friction in this direction, but it's going to be in that direction right there. So that's going to be the FFAB, right? And we also have P coming up right there. Now, I think that this friction right here, yes, it has to go that direction. So here's the F BC. Yep. So, sum of the forces in the y direction equals 0. And we're going to have P, that's the thing we want to try to get, minus F, no, in the y direction, dummy. We're going to have a negative 10 pounds and a negative, I decided to stop using my symbols and just put the numbers in, and then plus FNBC equals 0. FNBC is now equal to 16. Okay, so now F BCS, let's call it, mu BC times FNBC. That's going to be our 0.4 times our 16. Where are you? 16? Yes. Which is 0.4 times 16, or 6.4 pounds. Not a lot. We should do the sum of the forces in the x directions equal to 0 here. And so we're going to say that we have negative FF. Now let me start out with the positive one there. I'll start with the positive. That P minus FF AB minus FF BC equals 0. So P is equal to FFAB plus FFBC. We don't know either one of these yet. But for movement to happen, this has to be true, right? And lastly, let's see, we'll put this guy on here. We're going to have this guy down here, and he's going to have FNBC, and then here's going to be FNCD, and he's going to be trying to be dragged in this direction right there, right? But he's going to try to be stopped by this direction right here. So here's CD, and this is BC, same as this guy right here, right? They're opposite to each other. And then we also have the weight of C. So we have the sum of the forces in the y direction equals 0. And so I try to save some paper here, but it's just going to make a mess. Should have just gone down that way, but whatever. So I know this value. It's going to be a negative 16. And then this is a minus 3.5 plus FNCD equals 0. FNCD is going to be 19.5 pounds. So the FCDS is mu CD FNCD, or 0.35. times 19.5 and 0.35 18.5 times. And that's 6.825 pounds. All right, so I've kind of procrastinated trying to figure out a couple things. I guess maybe I'll go ahead and procrastinate just a little bit longer and come up with this last thing right here. So what we find is that in the x direction here, FCD plus FBC is equal to 0. So what we happen to know is that FCD is equal to FBC, right? So when those things are equal to each other, right up into the point of movement, right? So that's just a fact right here. So we can say that, and we note that which is greater, right? The of these two. Which one is smaller? So the one that's smaller is the one that's going to happen first, right? So this guy right here is larger than this. So this is the spot that's going to slip first. And when it slips, these two are going to be equal to each other. So the answer to this, so let me write this down. And, well, let me see also up to here. Okay, so when all right, so, okay, I see what happens. All right, so this one doesn't need to, yes, all right. So when, let's say, okay, so if this gets pulled, all right, so I'm talking through my logic here. When this gets pulled and this thing starts to move, if this right here is not succeeded, that doesn't mean it starts moving. It's when this gets when it overcomes this. But this guy right here still has that static friction. So I think what you're going to find, the solution to this is going to be this one plus that one. That's my thought process here. When P, now let me try to think of the way that I can phrase this so that it's clear. When P is okay, when motion starts, I'll write that way. When motion starts, okay. It will be equal, static friction force will be equal to this, right up into the point that motion starts. So when motion starts, you got to decide whether block B and C are going to move together or whether block B is just going to move independently from itself, right? Yeah. So it is definitely B is going to move independently without C. All right, so I'm going to say that P is trying to think of the phrasing of this thing. When motion starts, only B moves in friction and B is at static point. I don't know how to say that better. P is going to be equal to let's see what I wrote there. 3 plus 6.4, so it equals to 9.4 pounds. So P is equal to 9.4 pounds. I think that's right. I don't know. I'll do an update there. I'll go take a peek. I know I can probably find the source to this and see if I got it right. So I'll give you an update on that when I get around to it.